All right. Well, hello, Honors Algebra 2. Welcome to the second section of the notes for Unit 10. Today, we're going to focus on going kind of opposite of what we did in the previous lesson. So instead of graphing based on an equation, we're going to be writing an equation based on a graph. We're going to start kind of the same way, though, as we're going to try to identify kind of those three key features we talked about in our previous lesson, which were the midline, amplitude, and period. Now, in writing our equations, we're actually going to do that for both sine and cosine. And so we'll talk about first kind of how to know which one to start with, because there'll be one that'll make more sense to start with than the other. And then what we'll do is we'll incorporate that idea of the phase shift that we talked about at the very end of the previous lesson to move our graph to where it would work for either sine or for cosine. So starting with number one, let's go ahead and kind of identify what is our midline, amplitude, and period for this graph. So starting with the midline. I like to try to find it visually, and in fact this one's pretty easy. It's kind of the standard y equals 0 would be our midline. If you're not quite sure, especially on some of these other graphs, what the midline is, the other thing you can do is try to find the average between your maximum and minimum. So this maximum would be at a y value of 3, minimum would be at a y value of negative 3, and if you average those numbers, 3 plus negative 3 over 2 becomes 0 over 2, which is 0. So that would be kind of the other way that you could find your midline. Once you found midline, amplitude, you can find just by looking at what is the distance from that to your max or your min. In this case, that means that your amplitude is a 3. Lastly, your period. Here's going to be kind of the tricky part, is we had a formula from going from our equation to our period, but not from our period to our equation. If you recall, what we said was that the period, let me use a different color here, we'll use green, is that period was equal to 2 pi divided by the number in front of x, which we called b. Now, in order to get that to work, we now want to solve for b. And so if you recall, the way you solve for a variable in the denominator is that you just switch it with the other side of the equation, which means to go backwards, you actually end up doing the exact same thing you did before, just now you're taking 2 pi divided by your period. So if you're looking at your period, it looks like from 0 to 2 pi is where you go through one full cycle. So then your b value would be 2 pi divided by p, which was 2 pi. So it turns out that that number that's going to go in front of x is going to be the number 1. As a reminder of what those equations looked like, there were two equations that we were talking about. One was for sine, which was that y was equal to amplitude multiplied by sine of bx plus your midline. The other was that y is equal to your amplitude multiplied by cosine of bx plus your midline. And I think we've got enough information to fill out at least one of those two equations. It really now just becomes a question of, do we use sine or do we use cosine? And in the case of number 1, looking at the point where you started at, so at the origin, you start on your midline. And as a reminder from what we talked about in the previous lesson, if you start on your midline, that's where we're going to use sine. So for our first equation, we're just going to plug in all the values that we just found, which is that y is equal to 3 multiplied by sine of bx, so sine of 1x, plus our midline was 0. So I guess that's all we're going to have to actually write. It's going to be y equals 3 sine of x. Now, and a little bit later, I'm going to share with you how you can also write an equation for this graph using cosine. Before we do that, I just want to go through numbers 2, 3, and 4. Let's just get one equation down, and then we can go back and figure out the second equation for each one. Okay, so looking at number 2, let's first find our midline. And this one's a little bit tougher to figure out where that's going to be. It actually ends up being through y equals negative 2. And again, if you weren't sure, and if that wasn't kind of obvious to you, remember you can take your maximum, which was 2, plus your minimum, which was negative 6, divide by 2. That ends up being negative 4 over 2, and then that simplifies to be negative 2. So just take the average of max and min. For amplitude, we're now going to look at what is our distance from that midline to either a max or a min. In this case, the distance, I'm looking at -2 to +2, is a distance of 4. And then lastly, for our period, we look at how long does it take to repeat itself. So starting up here at a maximum, to get to our next maximum, that's a distance of 2 pi. So remember, to get your b value, take 2 pi divided by your period, which in this case was also 2 pi, and 2 pi divided by 2 pi is 1. Okay, so really the only thing we have left to decide is whether to use sine or cosine. Looking at that initial point, we were starting at an amplitude, not at the midline. That's our clue to use cosine to write our original equation. So writing that equation, we would say that y is equal to, our amplitude was 4 multiplied by cosine of bx, again it's just 1x, and then this time we actually did have a midline other than 0, so we'll put a -2 after. Alright, 2 more that we'll do before we go back and write our second equation. So, on number 3, in fact number 3 would be a really good one if you want to practice on your own. This would be a good one to try. I would say number 4, probably watch the video, make sure you understand kind of how I'm working through it. But number 3, if you wanted to pause and work through it and then just fast forward, check your answer, this would be a good one to do that on. Alright, so let's do it. For midline, we should have said the midline for this particular graph is going through a y value of +1. For our amplitude, going from our midline to the maximum value, that was a distance of 2. And then for period, we were going from 0 up to 2 pi. So then take 2 pi divided by that period to get your b value, which in this case, our b value is 1. Now again, in this case, we're starting at an amplitude. So our first point here at an amplitude, that tells us that we're going to be using cosine. So y is equal to 2 cosine of 1x plus 1, and there would be our first equation. Alright, one more to go, and then we just have to go back and figure out kind of how to go from one equation to the other. So number 4, let's kind of go through it and work it the same way we've done the previous problems, and the only real difference is going to be the period for this one. So the midline was pretty straightforward. This time our midline was through y equals 0. Next would have been our amplitude. Be careful with your amplitude and the labels. Going from midline up to an amplitude, if you notice that the labels actually have that at 0.5. So our amplitude is going to be 1/2. And our period, here's where it gets a little bit different. Notice that our period is no longer 0 to 2 pi. This time it's 0 to pi. So when we're looking for our b value, we're going to take 2 pi divided by our period, which is pi, and 2 pi divided by pi, the pi's are going to cancel. Your b value in this case is going to be a 2. Alright, so for writing our equation, we just have to look at what point do we begin at. In this case, we started at our midline. That's your clue to use sine. So we're going to say that y is equal to our amplitude of 1/2 multiplied by sine of our b value, which is 2x, and then our midline was 0, so we don't need to put anything after it. Alright, so that basically takes us through the kind of first equation for each of those. Now we just need to go through and figure out how to write it in a different form. So we need to talk about how to write it in the other equations form. So let's first talk about number 1. So on number 1, we said that this was a sine graph because it started at the midline. If we wanted it to be a cosine graph, remember cosine has to start at an amplitude. So cosine graph would have had to have started right up here. So in order for that to work, what we would have had to have done is taken our cosine graph and moved it to the right. And we would have had to have moved it to the right by a distance of pi over 2. So here's all we're going to do. We're going to keep our equation pretty much the same. So we're going to keep the 3. We're going to change sine to our opposite form, which would be cosine. And then we just need to use a phase shift to say to the right by pi over 2. And remember, for phase shifts, just like moving left and right, those are going to go opposite of what you would want to normally think. So to the right by pi over 2 is actually going to be minus pi over 2, and there would be our other equation. Now, a good thing to do, especially when you're first starting this, is to go and check, make sure that they do actually match up. An easy way to do that is to go to Desmos or use your graphing calculator, whatever you've got at your disposal. I'm going to go ahead and show you with Desmos what these two equations look like, and hopefully they'll be the exact same. So our first equation was y equals 3, and then multiplied by our sine of x. Let me get that function here. Y equals 3 sine of x. So here is that first equation. And if we did everything right, then we should, when we type in the second equation, still only see one graph. So let's see if we get that. So we type in y equals 3 multiplied by cosine of, and if we just leave it as x, notice that it's not going to be the same graph. It's going to start, like we mentioned, too far to the left. We wanted to move it to the right. And remember, we wanted to move it to the right by pi over 2. So minus pi over 2. And if you notice, once we do that, now all of a sudden we have a graph that matches. So, looks like it worked. Okay, let's try the same thing on number 2. So on number 2, we started with a cosine curve. And that was cosine because we started at this amplitude up here. We now want to start at the midline. So we really wanted to start it right here. You can do that kind of one of two ways. The longer way would be to move it to the right to where it would start like it would for a sine curve at 3 pi over 2. Now this graph didn't continue to the left very far, but actually if you went to the left, you could get that distance just by going pi over 2 to the left. So that's going to be how I write my equation, is instead of going to the right by 3 pi over 2, the shorter distance would be to the left by pi over 2. So when I rewrite my equation, y equals 4 multiplied by sine of x, to say left by pi over 2, we're just going to put plus pi over 2, and then the rest of the equation has to be the same, so the minus 2 would have to come after it. Okay, let's do 2 more. In fact, number 3 again would be a nice one for you if you wanted to kind of try one on your own. To do that real quick, and then we will talk about it. Okay, so number 3, kind of the same idea as what we talked about on number 2, which is that for sine you want it to start at your midline. So again, this one's a little bit easier to see. You can either move it to the right by 3 pi over 2, or the shorter distance, which again I'm going to use, is going to be to the left by pi over 2. So we'll just copy down that same equation, switch from cosine to sine, and we're going to move it to the left, so plus pi over 2, and then put your plus 1 after it, and you're done. Okay. Number 4 is a little bit tricky, so please make sure you watch through this one. It is probably the most difficult one on this section of the notes, so I'm going to take my time working through this and hopefully make sure that it all makes sense. So first thing is we want to rewrite this in terms of cosine. So looking at our graph, cosine, we wanted to start at an amplitude, pretty easy to get there, move it to the right, half of pi over 2 would be pi over 4, so that'll be how far to the right we'll move it. Now here's where you have to be careful, because that part's kind of the easy part, is when you write this, you're going to leave the 2, but then the x is going to go in parentheses with your to the right by pi over 4. So x minus pi over 4, and then close both sets of parentheses. If you wanted to write that a little bit differently, you could distribute the 2 that's inside the parentheses to say 2x minus pi over 2. Either one of these would be correct. Now, I only mention that because on the quiz on Friday, I will probably have it in the simplified form, which will be the second form. So just be ready to get there. And again, that was just distributing the 2 to both x and pi over 4 in order to get those questions on the quiz right. Especially those multiple choice questions where you might get a right answer, but then have to find what the equivalent form is in order to get the answer right. Let's just double check this one. Let's go back to Desmos, make sure everything looks good there. So our first equation, y equals 1/2 sine of 2x. Let's type that in real quick here. So 1/2. We'll just type that as 0.5 sine of 2x. Our second equation was pretty much the same. Y equals 0.5 cosine this time of 2x. And then we moved it to the right, so minus pi over, not 4, but pi over 2. So you can see where those parentheses became very important. If you did just have pi over 4, you'll notice that it doesn't quite get you to where the two graphs match up. But when you remember to distribute the 2 that was inside the parentheses, you do get two graphs that match up with each other. All right, a little bit shorter video this time. Hopefully you were able to follow through that. The next lesson that we'll talk about is going to be graphing tangent. So we'll talk about kind of how the graph of tangent works, as well as some of the applications for that. So we'll talk about those in our next video. But for the time being, have a good rest of your day, and I will see you next time.